Hello again, welcome in the first Embedded System Lab lecture. In this lecture I'll give you an overview about the Arduino board. This is Arduino Uno board, and just an overview of the software environment, the IDE environment, how you can download it, what the structure of the Arduino sketch. So keep watching. Getting started with Arduino, you will be working as a team, and each team task will be explore Arduino Uno and the IDE environment. So why Arduino? The main reason is because this is the college recommendation first, and there are many other boards, many other development boards. Why Arduino? Well, it's an open source. The IDE is free. You can download it. It's free to use. It's on multiple platforms: Mac, Windows, Linux, and there are many Arduino shields you can use. It's inexpensive. The board is just for $6 to $7. There are many projects online. You can do many projects. They are unlimited with the Arduino. Also, in the next semester, I will teach you on the second course of the embedded system. We will explore the FPGA. So the Arduino is a very good place to start with. The Arduino environment consists of three parts: the Arduino Uno board, the IDE, and the Arduino shield. With this shield, you can build a hardware without knowing anything about hardware. We will not use shield during the class. We will use chips, integrated circuit to fully understand how these hardware software systems are designed. The Arduino Uno board, the IDE will be explained in the next slides. So what the lab component? We will use sensor and actuator. So what are sensors and what are actuators? Well, sensors are used to receive information from the environment. With this sensor, you can sense some information from the outside world. So the sensor will be as an input devices. The Arduino will always read from this sensor, will read the information from the environment. So sensor can provide simple information. For example, the thermostat will give you a temperature. Photoresistor will give you the intensity of the light. Push button will give you some information about the user pressed this push button or not. The touch panel, the potentiometer, it will give you some information about how much the knob is turned. Okay, they also can provide more complicated data. For example, camera as a sensor to provide some complicated frame, some complicated pixel, Bluetooth communication, and etc. So we use all these sensors, the temperature, the photoresistor, the push button, and so on. We use them to receive information from the environment. We will read this information. So the sensor is an input devices, and the Arduino will read from these input devices. What are actuators? Actuators causes event to occur in the environment. So the actuator is an output. The Arduino will write to the actuator to cause some event. For example, a simple actuator, an LED, will cause the event which is the on or off of the LED. Or the LCD is a simple actuator. It causes an event, for example, type some text on the LCD. More complicated actuator is the servo motor. The Bluetooth here can be used as an input port, a sensor, or output port as actuator. More complicated, as I said, the servo motor. You can cause an event from the Arduino. You can output a voltage to make the servo angle rotate. Servo motor is very helpful, especially in robotics, as you will see in your projects. So, what is the breadboard? One of the important lab components is the breadboard. You should be all familiar with the breadboard. We work with the breadboard together on the electrical lab and the electronic lab. So, embedded system component, as we said, there is a hardware and a software. So these hardware need to be connected. How we connected the hardware? We have two methods: solder them or wiring them. In this lab we will use the wiring method. Why wiring method? Because it's fast, non-permanent. Maybe on your project we will solder some things. If you want to go further and make a prototype, maybe enclosure or with 3D printing, we should use the soldering. Okay, this is the breadboard. It contains this column. This is line are connected together. This can be used for common ground, and this line also connected together. This can be used for common voltage. This row, each 5 holes of a row are connected together. So this is a 1 point, this is another 1 point, and so on. Now the Arduino board. This is the Arduino board. The most important part of it, this is the microcontroller. All the magic happened here. This Atmega 328 microcontroller. This is where your program will be. There is also another microcontroller, another microprocessor here, which is Atmega 16U2. This is only for handling the USB communication. This is USB connected from computer to the USB. This processor has only one job, which is handling the USB communication with the computer. We have the digital pin 0 to 13. We have 14 digital pin. We have an analog pin, 6 analog pin from A0 to A5. We have this for DC input, for power supply. We have a reset button. This is a reset button. We have 3.3 power, 5 volt, ground, voltage in, and also we have in-circuit serial programmer. This is in-circuit serial programmer, and this is in-serial circuit programmer. We use these for programming the microcontroller. In theoretical lecture, I mentioned that the software consists of a firmware and the program the user writes. The firmware, the user cannot change it, cannot modify it, but sometimes the user need to upgrade this firmware. How we can do that? We can do that by using this pin. We can change or upgrade the firmware of this processor by using this pin. We can change the firmware of this processor by using these pins. Okay. Arduino pins. How we can designate the Arduino pins? We can classify them with two methods. We can classify them as input pin or an output pin. The output pin, as I said, is for the actuator. With output pin, with actuator, the Arduino will write data on this pin, while the input pin is for sensor, and the Arduino will use a read function from this pin. The output pin controlled by the Arduino to control other device. For example, the Arduino may want to control LED, may want to control a servo motor, or will control an LCD, for example. When I said control by Arduino, what I mean by this statement? What is control? Actually, the Arduino will control the voltage on this pin. The voltage controlled by the sketch, the program you wrote. For example, if we have a lid connected to a pin, an Arduino board, then we write a code sketch to assign some voltage to this LED. Maybe we will assign them with a 0 volt to turn the lid off, or with a 5 volt to turn the lid on. So the Arduino will control these devices by controlling the voltage on this pin using the IDE sketches. Also, the servo motor is an actuator, the output pin for controlling the angle of this device. What are the input pins? Input pins are controlled by other component, controlled by other environment. For example, a push button is controlled by the user, and the Arduino only read its status. The outside environment will control the voltage on this pin. The user will control the push button. The outside environment control the voltage of this temperature sensor. The user also will control the voltage produced by this potentiometer. So the input pin are controlled by other component, by the outside environment, and the Arduino only will read this voltage from these pins. The other way to distinguish between pins, you can classify it as a digital pin or analog pin. A digital pin is used for read and write a digital voltage. It's from D0 to D13. It's only the voltage on this pin, 0 or 5 volt. The analog pin, on the other hand, only read analog voltage. The Arduino cannot write. The Arduino cannot write or create analog output. This is a very important note. Keep aware of this note. It only can read analog voltage and use A to 0 to A5 to read the analog voltage, and it cannot create an analog output. Why? Because the Arduino doesn't have digital to analog converter. It only have analog to digital converter for the input pins, but for the output pin, for the analog, it doesn't have digital to analog converter. But we can fake it. We can fake it, the analog output, by using pulse width modulation, as you will see in the next slides. This is the hardware. I explain the hardware. I explain the sensor, the actuator, the breadboard, the sensors, and the board itself. Now I will explain the software. The software of the Arduino consists of two parts, the firmware and the application. The application is programmed by the user. The application is just the code that describes the embedded system main function, while the firmware cannot be programmed by the user. It supports embedded system main function, for example, handling the USB, the power, the reset, etc. You cannot change, but as I said, you can upgrade by using the circuit in pins, as I explained in the first slides. But in this class we will not do that. We will only write application program. The microcontroller AVR at Mega 328. This is its specification. The voltage needed to work is 5 volt. Some board need 3.3 volt, but Arduino only work with 5 volt. The input voltage from 7 to 12, but you can provide it with 6 to 20, but the recommendation voltage, this is our recommendation voltage, the digital pin, the analog pin, the current, it will provide 14 milliampere current with 5 volt and 15 milliampere with the 3.3 volt. It has a flash memory and EEPROM and clock cycle 16 megahertz. That means it can perform 16 million operation per second. The IDE, Integrated Development Environment, this is, you can download it from the Arduino website. I will give you the link in the next slide. When you first open the IDE, you will see this sketch. You will be see two function, void setup and void loop. Void, it means it return nothing. Void setup, you just use it to put your setup code. For example, the pin mode, the initialization of serial, for example, the variable declaration. While the loop function, you put your main code here. Okay. We have this is a compile the code. This is for compiling and upload the code. This is used to upload the code from your computer to the Arduino. This is for new sketch, open sketch, save code, and this open a serial monitor. The setup function present in every Arduino sketch run once before the loop. Okay, as I said, it ran only once. It can be used to set the pin mode, initialize serial communication, or declaration of variables. The loop function, on the other hand, is present also in every single Arduino sketch. This code happened over and over again, and in the loop is where almost everything happened. So this program is also is a generic program, just to find everything is work okay, nothing problem with your board, nothing wrong with your IDE. So we will use the Blink program. This is a generic program. So first of all, you should download the IDE from this link. It's a free. We all like free. From IDE, select, you must every time open the IDE, select the board. From tool board, choose your board, connect your Arduino, then choose the port. The port must be chosen after you connect your Arduino to the PC. Open the Blink example, compile the program, and upload the program. When you upload the program, this is the Blink example. It's very easy. It just declare pin 13 as an output pin. What connected to pin 13? Pin 13 contain a built-in LED. This is a built-in LED. Then we just write high to this pin and low to this pin, and we will use a delay function for 1 second. This is a generic, as I said, a generic example like hello world. We cannot use hello world with the Arduino. Why? Because we don't have an LCD. The hello world is the generic example with every programming language. The first thing you do with every programming language, you just type hello world on the screen. In the Arduino, we don't have screen, so the generic example is always to flash or modify something with the LED on pin 13. So first we declare the pin mode as an input. We digital read, this is the function, provide output high or low to a specified pin. It take 2 arguments, then the pin number and the value. We use delay. This causes some program to suspend for duration of millisecond. And that's it.